It's Don here from the board. Thank you for coming along and checking out another one of our videos. Today I'm going to be showing off another one of my 3D designed and printed diode bending tools. So a couple of weeks ago I did a video where I showed off this little guy which was designed to basically bend diodes evenly for the purposes of through-hole PCBs. And it was designed primarily for approximately 7 to 8 millimeter gapped holes with the standard through-hole diode. Now, since that time, I was asked as part of a innovation challenge if I had other ideas that I could throw out there to help encourage people come up with their own ideas. And I had been asked if I was going to do a single leg bending tool for the purposes of hand wiring. And it took me quite a while to think about how I would actually design it and what kind of end resulting tool I wanted. My initial design was actually a base unit where the diodes could fit in it, and it had a flap that allowed me to push down and bend the diodes evenly on one leg. But in prototyping and printing, it didn't work out really well because the hinges that were printed in situ, not an assembled piece, actually broke off. They were really weak, they were really thin, and it had, wobble issues, and they just snapped. So I went back to the drawing board, as it were, the digital drawing board, of course, and rethought about how I wanted things to work. And I kept some parts of the old design, and then I revamped it and turned it from a one-piece print with moving parts to a multi-piece print that you had to sort of do stuff with to make it work. And so let's have a look at what I ended up with and how it works. Just gonna switch over down to the desktop. So of course there is a little bit more of a close-up of my very basic diode bending tool where the diode sits across the middle there, and then you put the other half on top and you push, and you end up with these guys over here on the right, which is evenly bent on both sides to a certain degree as long as you're careful. And then this monstrosity, which is also designed for 25 diodes, because you'll see it's the same cartridge length, is going to do single legs. Now here is some that I prepared earlier just to give you an idea that it's actually designed to bend them at 3 different lengths. These lengths are relatively arbitrary to my original design. Now why I say that is because I didn't know what kind of length and distance you want to have your single legs bent for hand wiring. And now that I've actually had this successfully printed, and you can see what I'm trying to fit here is, if on my switch tester for a standard ortho, it does kind of allow me to place it there, and then I can still solder the next one along, and then I can trim it. So it just depends on how much sort of overlap and overhang you want, because that's obviously too far down, but if I slide that up, that would be fine. Whereas this one is kind of a good length because you can see that gets the diode body in between the 2 different switches, so there's plenty of overhang if you need to make your soldering connections. But of course some of these might not be enough to gap the spacebar. So I thought, well, if you made that length, it's a little bit off camera there, that's sort of like the minimum length that you could get. You could potentially gap very close to the spacebar or something like it. It was just a bit of a thought. And or your long switch here for your shift stabilizer switch, that could actually make it across. Whereas if you had, I did find that when I was doing my 40%, if you bent it too short, then it made life a little bit more difficult kind of thing. Anyway, it was really just a design option that you could do multiple lengths. Now my design of course is a very basic one, which means anybody else could take that same concept and make their own and modify the gap distances if you wanted to do that. But here it is. It's a 3-part print, and there is a sliding C-shaped kind of section there. There is a sleeve section here, and there is a base unit which is here. The concept here of course is that you've got 25 slots, and each one of these rows here with the large openings is actually for the diode body to sit in. And depending on how close to the single edge on this side is how much of a leg length bend that you're going to get. And so you can do all of them the same length, or you can do some at a different length. It's entirely up to you. And of course, what I'm talking about is you can change as part of a design, if you were to recreate this yourself, the gap spacing between these diode bodies to suit whatever gap distances you want. Now these are 5mm gaps, so the increment is actually 5mm. How this works is you're going to load your diodes into it. You put this sleeve, which sits over the top, and it holds the diode bodies in place, just like that. There's already guidance grooves here for the bending, and then with the non-bending component on the bottom, which acts as a guide for this sliding piece, you drop it into the slider, and then you just push, and that should bend your diode legs. So I've got a couple over here, and I thought we'd just do some actually on the video so you can see. We start off with some straight ones, and they're not some dodgy hand bent thing, and we can check them out. So let's just put them in the middle, make life easier. We'll go for a 1, 2, and 3. So we can have our 3 different lengths there. You can, I don't know if that's, there we go. So we've got them in 3 different positions. They're relatively snug with the measurements. There's a little bit of movement, but that's okay. You're going to take the top sleeve, you're going to slide it over the top of the cartridge, just like that. And now you can see they can bounce around a little bit, but they don't really fall out and they don't go anywhere. So they're pretty much locked in place there. And then we're just going to flip them upside down. We're going to get our tool here. Well, actually, there's no reason why you have to flip it upside down, because we can just check that they're not moving around. They're still sitting in their diode body slots. You can actually take the tool and you can put it on the top like that, as you can see, just like that. Oh, I'm not sure if it will show you. There we go. And whoop, push them through. That was probably a little bit more violent than I needed it to be. And the legs have been bent. Now, of course, that's still being held because the diode bodies are trapped in there. But let's take the sleeve off it. There we go. And tip them back out, and there you go. Now, you'll notice that they aren't 90-degree bends. They're not 90-degree bends. But because the metal's already been stressed at that point, you can now complete the bend yourself, and they should bend at the joint that they were bent at. So it's really more of a bend encouragement tool, really, more than a complete bend. And that's only because in order for them to hit 90 degrees, because the metal's elastic, you will actually have to bend them past 90 degrees, and then they'll come back to 90 degrees. And that's the same with my dual-sided bending tool as well, because you'll notice that even with this, they're not actually bent 90 degrees, but as I said earlier, when you drop them through the PCB, it's handy simply because that slight angle holds them in when you're actually tacking them down. So there you go, and you've got your 3 different lengths. Now, of course, we can go through that again and hopefully not be so violent, but this time we'll just do them all at the same length, and we can check them out for how consistent they end up. So we'll just drop them into the middle slot, just because I can. Middle slot seems to be a good idea. So we'll put the sleeve back over the top again, lock that in. We can put the piece, and this time we'll do it from the other side. So you can see the 3 legs there, and just like that, you can still see the 3 legs are there. They're sitting inside their little grooves, and we'll just kick that piece out, turn that back around, pull it out, and voila, 3 legs with, I would say they're pretty consistent in how that bend angle is. There we go. So that is my, of course you can just give them a nudge to bring them back up to 90 degrees. Just like that. So that's my single leg diode bending tool. Now I will have this also on Thingiverse with the link below the video, and yeah, feel free to take the design. You can print it as is, or if you feel like taking the design and concept and modifying it to suit your gap distance or bodies, if you want to do resistors or any other components, no issues there whatsoever. The only thing is the tolerances on my print here were incredibly fine, to the point that the pieces did not fit coming out of the printer. The model has been drawn to be a perfect fit, as it were, and due to oozing and whatnot on FDM type model printing, I had to do quite a bit of sanding within the C shape on both sides. I also had to sand around the actual tabs here, because that was the only way that I was going to get it a good fit. And I also had to do a bit of sanding along the base block here on both sides so that it would move freely, because it was so tight that upon putting it in, it wasn't actually coming back out. It was binding against the layers, because this was printed vertically, this was printed horizontally, so the layers are actually in opposing directions, 90 degrees to each other. So, and you can kind of see, maybe if the camera will focus. Nope, doesn't really want to focus, but well, the light will show it there. There's a bit of sanding marks that you can see that I've done on the edges to reduce the amount of binding it has. Rightio. And of course you can make them either bigger or smaller depending on how good you are with your modeling and slicing or editing of existing STL files. So thank you for checking out the video. Love to get your comments about it. If you like the tool, if you don't like the tool, if there's anything else that you would like me to have a crack at designing and creating and printing and testing. My home print is not very good, so this was actually printed at another printing place, which I don't always have access to having prints made, but you know, if I do and I can, I will. Simple as that. So if you like the video, of course, please hit like, share, and of course, if you've never subscribed to our channel before as well, please hit subscribe. Always trying to do some cool and interesting things in regards to mechanical keyboards and related peripheral things. Right, that's a wrap. And of course, you can also find my single leg diode bender on my Thingiverse as well. So thank you very much for coming along, checking out the video. And of course, as always, until next time, happy clacking.